All right, so my name is Caroline DeLinks, and I'm going to be talking about de-icing salts and the environmental impacts they have. So de-icing salts are salts that are used to melt ice and snow by lowering the freezing point and preventing a bond from occurring between the pavement and the ice. It's just regular salt, just not purified, and it's composed of sodium chloride in its mineral form, which is called halite. De-icing salts have mineral impurities, which cause the discoloration, making them grayish or brownish. And it took me a bit to figure out like mineral impurities, and the definition is just elements not present in the pure compound, and they impact how a mineral will look in color. So a ruby, for example, if it has less than 1%, even at least 1% chromium, it will look red, but without that 1% chromium, it'll just be colorless. So there can also be other additives to de-icing salts, such as sugar and sodium hexacyanoferrate. And those are just anti-caking agents. It makes distribution easier while putting it in the truck, and then they usually mix it with water and spray it, or they'll just put it right on the ground. And these salts have detrimental impacts on the environment because freshwater creatures, for example, when the salt gets washed down and pollutes the groundwater or the freshwater ponds and lakes, from like rain rinsing it down, the fish will have an issue because they live in a freshwater environment, and so there are low salt concentrations both inside the fish and in their environment. So the whole thing is an isotonic relationship, but when large concentrations of salt suddenly wash into the environment, the water inside the fish is going to move towards the high solute concentration, which is now in the environment, creating a hypertonic environment for the fish, and they'll start to dehydrate. And I'll get a little bit more into that. But a little fact is that 1 teaspoon of sodium chloride can make 5 gallons of water uninhabitable for freshwater species. Plant life also gets impacted when it gets sprayed by the de-icing salts in the winter or when the groundwater is polluted, because salt burn can occur and desiccation of the plant bud scales, which leaves them vulnerable to the environment, which is usually really cold, so it'll freeze. Let's see, sodium chloride ions also separate when dissolved in water, and this displaces the nutrients in the soil, such as potassium and phosphorus, and that leaves the plants absorbing more sodium chloride than the actual nutrients they need. And our drinking water public water gets impacted because, again, the runoff water and high sodium levels can impact blood pressure, and chloride doesn't really have an impact, contrary to the beliefs. It's just the association between like chloride and sodium, that mix up, but it's the sodium that does the damage. Alright, sodium chloride, NaCl, its chemical structure is a cubic unit cell, and it is described as face-centered cubic unit cell, so FCC. Sodium chloride specifically is a face-centered cubic unit cell, but a cubic unit cell is the smallest repeating unit where all the angles are 90 degrees and all the lengths are equal. In sodium chloride specifically, there are 4 cations and 4 anions per unit cell. The functional groups are the carboxyl group and the acyl chloride group, and it comes from seawater or rocks deep underground. So I started talking about this already, but through osmosis, which is what living cells use to maintain a balance of water and intracellular fluids, The fish are suddenly immersed in an environment that has a much higher salt solute concentration than they do inside of them. So the water exits their body from their membranes into the surrounding water because the salt calls to it, supposedly. And that causes them to dehydrate. I mean, the water leaves their body. Plants, same thing happens. They get sprayed with salt when cars pass by, or the runoff water, etc. But more specifically in plants, chloride is kind of a bigger issue because the chloride levels in moderation is a micronutrient that plays a big role in the stomatal guard cell by providing balance anions. And the stomatal guard cell opens and closes based on the turgor, which is how much fluid is inside the cells. So the more dehydrated the cells are, the stomatal guard cells, the openings, the pores will close and not allow for carbon dioxide intake. And too much chloride will also interfere with the process of photosynthetic carbon dioxide fixation, which is the first step in the Calvin cycle, and the enzyme rubisco, which ribulose biphosphate carboxylase gets impaired. And also the swelling of the thylakoid lumen impacts photosynthesis. Those last two things were very tricky to try to find more information on, and it's late. So here we are moving forward. Our water, drinking water, tap water, gets impacted because the sodium chloride infiltrates the groundwater. Again, it pollutes it. And on our skin, that could be beneficial because it absorbs dirts and toxins and accelerates the wound healing process. But consuming salt for human beings is not very good because it will result in high blood pressure as your body holds more water inside, since the salt is drawing water towards it, and we've consumed the salt, so it's inside us, and it's keeping the salt inside us. The water is the salt is keeping the water inside us, and that puts pressure on our blood vessels as there's so much water inside them. And that makes your blood pressure pretty high. Here are my fact sheets. I kind of just went over both of these things. Yeah, I'd say just pause if you want to give those a look. There's some good pictures in here. Here is the cubic unit, the crystalline formation of salt. And these are my citations. Thank you for listening.